Welcome, ladies and bitumen. Thank you for joining us. I can't resist. Thank you for joining us for another awesome episode of our Galaxy and Beyond with Anthony and Juju. And first and foremost, we'd like to apologize for not being able to broadcast on our normal scheduled time and day. But we are here with you now. And if it isn't ever in our power to do so, we will be always going live at Wednesdays on 7 p.m. Okay, just to let you know. So, but sometimes, the job calls and it's just nothing you can do, right? So it is what it is, and we all good with it. Families first, and that's how we take care of our families. So that's what it is. So, not to delay, excuse me, little tongue tie any further. I'm gonna get right into it and introduce, of course, the other host of our Galaxy and Beyond, and my teacher, the great Starman himself, PK official Anthony. What's up, Anthony? Want to say hey to the
What's
people real
happening?
quick?
What's happening, Miss Juju? You doing good?
Oh yeah, I'm doing great.
Yeah, I want to apologize to everybody for yesterday. I got off late, but like you say, it is what it is. Got to feed the family,
Got to
but
see the family.
we ready. It's
We ready.
you
Got
know,
some.
talking about
Yes.
these black holes, and you know, refer a little bit to Dr. Farrar and the conversation we had, and y'all make sure y'all go check that video out. That was just part of it. I probably drop the second question tomorrow, or sometime tomorrow I get a chance. And then there's a third part to it, and then another interview or conversation I had with him. So I got plenty coming up, and it's all dealing with black holes, because that's his
Specialty.
yeah, and he
Mhm.
teaches. He's a college professor. So yeah, y'all make sure y'all check that out. But you know what we say, Miss Juju? When you scientifically literate, they can't drag you down to their level and beat you up with experience. So let's
Facts.
get it.
Um, of course, I'm going to do our mission statement as we do every show, because we just have to reiterate it, at least for season one, why we're doing what we're doing, and why we have a passion to do this, right? But to give a little reference, Dr. Farrar is actually an astrophysicist, a professor, an astronomer at the University of Hawaii, and Anthony
Mhm.
has had the extreme pleasure, I'm so jelly, to actually go to the observatory and talk and chat with Dr. Farah. We've actually interviewed him on the PseudoKillas platform. I believe before we did Dr. Moya McTeer. So if you want to catch some of our early interviews with Dr. Farah, just please go into the PseudoKillas channel on YouTube and you can catch that in our archives. And he is a pretty awesome, cool dude. And
Yeah.
him and Anthony are like straight best buddies, and it's so tight. And hopefully, we'll be bringing him on very soon after finals and after he's done with all of his professor duties or whatnot. But
Well, Miss Juju, I want to make a quick correction.
okay.
I hadn't had the chance to meet him, but
Oh, okay, okay.
we've conversed. Now, when I went to Hawaii, he was on a different island
Oh,
than
okay,
I
okay,
went
okay.
to, so we
Correction.
couldn't actually meet. But yeah,
It's
we've
coming.
had several conversations. Well, not several, but we conversate.
Yeah,
You know what I'm saying? So
he's
he
cool though.
guides me through this, especially with the black holes. That's
Yeah.
my teacher. You know what I'm saying? So I
So
just
before we
want to
get
make that
started,
clear.
oh, I'm sorry, Anthony. And ain't
No, I
no
was just
way.
saying I wanted to make that clear. I don't want nobody going around, oh, he met the, no, I
He
never actually
lying.
met him. You know what I'm
Yeah,
saying? But yeah.
yeah. And just a note, man. I finally got that upgrade. I got that Mac. That 19 excuse me, that 2024, that Mac Pro 16-inch with the 3 MP3 chip, whatever. So yeah, I shouldn't be lagging, talking over nobody, nothing. Crystal clear screen. And I got about 40 tabs open. It's straight. It's driving like a Benz. It's
Yeah.
beautiful.
That's what's up.
So yeah, we upgraded the technology so we can give you better
Hmm.
programming and better content. So
You
that's
got
it.
to upgrade in life. You know what I'm
Yeah.
saying? You can't
Yep.
stay where you at. You got to upgrade. Hey,
That,
that's an upgrade.
That's definitely
You
an
know what I'm
upgrade.
saying?
That's beautiful.
Definitely.
We're gonna get into that one show strictly on that telescope, y'all. But y'all ain't ready. Y'all ain't ready. But
Yeah.
we gonna get to it. But before we get started, we have to give our mission statement, and I promise to be quick. We'll be quick because we got some other business, ladies and gentlemen, to attend to after this show. So make sure you catch us again on Community of Skeptics or the PseudoKillas. Not sure which one, but we definitely gonna be live.
Mm-hmm.
So our mission statement. Again, welcome to our Galaxy and Beyond with Anthony and Juju. We decided to do something a little different, switch it up, change the narrative a bit in the current scope of conversation in the community. We also wanted to motivate and stimulate scientific interest amongst the people of our communities, especially families, with the hopes of positively impacting the lives of our children, who are our future and legacy, right? This show, Our Galaxy and Beyond, will primarily be focused on the latest news and discoveries concerning the James Webb Space Telescope and all things concerning space science, our galaxy, and our universe. But of course, we may include other matters of science that we deem important or just fascinating. We also want to be a resource for scientific information, such as YouTube channels and other social media links, providing access to science programs, space camps, training courses, events at your local university or planetarium, and anything that is geared towards allowing one to become actively engaged in increasing scientific literacy or training and education that could possibly lead to one becoming an expert in a scientific based field or profession. So, with that said, welcome to Our Galaxy and Beyond. This is season 1, episode 5. And what is a black hole? Let's get it popping. So, Anthony.
Okay, before we get started, I want to, shout out the chat. Appreciate everybody for joining in. Omar Reed, my dude. Peace to you, my brother. Orion Nebula. Peace to you. Montu 2.0.
What's up, Orion
Appreciate you showing up. Abjuwell. Appreciate you, my brother, for coming through. Ghoul. Yeah, the Bitterman hoes. That's what it is, baby. Ken Folk. Jack Thorne. Appreciate you, my brother. Cuban Crisis. Appreciate you, man. Kent. Miss Gemini the Goddess. Thank you for showing up, baby. King Sosa in the house. Mm-hmm. We got Miss Bennett. Thank you, love, for coming through all the time. Major supporter. Mac Rob. Appreciate you, my brother. Appreciate you. Mongo. And yeah, appreciate that, man. Appreciate that. Yeah, this my baby. This my workhorse I got right here now.
Yeah, it's beautiful.
Get in. Appreciate you, dude, for coming through. Who else we got?
Did you call out Gemini the Goddess, my sister?
Yes, ma'am. Oh yeah.
I'm gonna call her out again. I'm sorry,
Oh yeah. Shout out again, then Miss Gemini the Goddess in the house.
Yes. Unscrambled minds, ladies and gentlemen. Mac Rob, PseudoKillas official. Hey.
And hey, Mongo, yeah, this is a camera right here, Mongo, and this is a camera as well.
That's hot.
So both of them are cameras. This one guides the telescope, the mount. This camera and this here tells the mount how to keep my object centered. And this camera is actually what I use to take the pictures. And this is a computer. Everything runs through the computer. The computer runs the whole operation. So that's the setup right there. But yeah, this is a camera. But I think they may have been talking about your camera, Miss Juju. They say you look good on that new.
Thank you. Thank you. It is crispy, ain't it crispy? It is. Thank you. I appreciate it. So, you ready to dive right into it? This is gonna
Let's get it,
fun.
baby. Let's get it.
Listen, not only is it gonna be fun, but guess what, y'all? I got lots of visuals. I got pictures for days. So, let me see. Let me see if I'm going ahead and share one before I start running my mouth. Let me see where I want to start at, y'all. Look, I got so many. I don't even know where to start. Oh my God. Just beautiful, beautiful stuff. Let me get into it and I'll figure it out because it's so many. So, yeah. just to do a brief recap of the James Webb Space Telescope first images and what scientific answers that it unveiled for us. Meaning, like, so the James Webb Telescope is revolutionizing the information that we're getting. So any information we already had, it's like improving it tenfolds, right? And it's also collecting so much information that it's actually producing way more questions than we had before. And it's just y'all don't understand how I'm always flabbergasted and almost speechless for words to say that it's absolutely amazing. I was just speaking to Anthony earlier how much fun that I'm having. You know, the more that we do this show, the more that I getting this fever to want to know more. You know, when you think of astronomy or astrophysics, you think, kind of boring because, it's kind of difficult. It's not easy, but it's like once you dive into it, it's like you fall in love with it and then it becomes addictive and you cannot help it. And I literally cannot help myself. So, yeah. The scientific answers that it's unveiled for us, the James Webb Space Telescope was launched on Christmas. You know what? I'm tripping, y'all. That was so wrong. The James Webb Space Telescope, was launched on Christmas of 2021. We got our first images back like in July 2022. But it is continuing to defy the odds of what we thought was humanly possible to discern as far as information concerning the known universe, right? Again, we have been completely amazed at the discoveries it is continuously making on a daily basis.
Yeah, it's off the chain.
Off the chain. And so I hope when you all are listening to the show, if you're really that interested, please take out, some pen and paper and take some notes because I'm constantly dropping so much detailed information. And remember, I hate to talk out of depth, but remember that description box. I got some amazing sources for this show for you in that description box. And I have some amazing link shares. So make sure that you check those out, okay? I'm always going to have something new and different. And I trust you by the end of season 1, or you know what I'm saying? It's going to be something there for everybody as far as the link shares and what platforms you can go on, what channels on YouTube you can go on to help you better understand the information that we're disseminating here, or, just for fun, and something that's enjoyable for you and the whole family, right? So what is the black hole? Well, first of all, the black hole is some of the most fascinating objects in space. Not only are they extremely dense, but the gravitational pull is so strong that light can't even escape its grasp, right? But what's so fascinating, and before I give it away, can anybody tell me, it may be a couple answers, so I'm not gonna hold you to that, but if you can, tell me the closest black hole to us. If you know it. I don't care if you Google it, but go ahead. But I think some of you would be shocked to know that the Milky Way contains an estimated 100 million black holes, right? The detection of black holes has been extremely difficult and a bit tricky, to say the least, right? Our galaxy has its very own supermassive black hole that sits in the very middle of it. Our black hole is named, ladies and gentlemen, I like to say that. I don't know. It should be named Good Juju, Bad Juju, because literally, black holes is a good thing, but at any moment in time, it can literally, wipe out our whole existence, right? So
knock us out of here.
Out of here, right? So the black hole in the middle of our galaxy is actually called Sagittarius A. And since my birthday is December 13th, I like to think that's me, right? Thank you, the evolutionist, and thank you for joining us. You got it. You got it right when I said it. The evolutionist, it is Sagittarius A, sitting in the middle of our galaxy. And I guess that's going to be our first picture.
That's it.
Yeah. Let me go ahead and give y'all Sagittarius A real quick. I tell you, I got pictures for days, y'all. Y'all going to be sick of me.
And that was a nice discovery. Now, the telescope that I did go to in Hawaii, that was the one that was used to discover it. They didn't get a picture of it, But you know, we'll get into how they got that picture. But the one that the Cake Observatory on Mauna Kea, that's the one that was used by Andrea Gies, is the scientist, her and her team. And what they did is they studied the stars that orbit that black hole. And it's a bunch of them, you know what I'm saying? But they found these stars moving extremely fast at the center of the Milky Way.
Right.
And they were all orbiting a certain point, even though their orbits were different, but they were all orbiting at one point. So that was the discovery of Sagittarius A. Sagittarius A star, Sagittarius A, SAG A, you know, it's a lot of names for it. But yeah, that's it. Sagittarius A.
So, dang, I want to go to here real quick because you talk about the orbiting, right? So I just want to show this real quick. If it's right, I'm gonna let y'all look at that.
Yeah.
So this basically is showing a simulation of the orbit of some of the stars towards the center of our galaxy orbiting around Sagittarius A, or the black hole, which what Anthony was just discussing. And that's something we'll get into later, but I can kind of tell you a little bit now, is that that's kind of how like Anthony was saying, they knew that, you know, there possibly was a black hole because of the orbit. And we'll get into maybe that's almost the only way they really can detect the black hole, right? Because black hole doesn't emit any light, so you can't even see it, right? So the only way
you can only detect the effects that it has on other things. And one of those stars, it's on a 17-year orbit. So they were able to watch that one star, because she's been doing this work for over 20 years. You know what I'm saying? And they're able to track that star's orbit to 17 years, where it makes a complete orbit. So that was pretty dope. You know what I'm saying? That y'all need to check into that. They got on National Geographic, they got a real good documentary about it, you know, about what you're actually showing right now. So yeah, that was pretty dope.
About the orbiting of the stars. Yeah. I'm every time I talk, I'm gonna keep a visual with y'all so y'all can really grasp and understand it. And I'm gonna show you another one that looks similar to this, but it's different. And you're gonna see a bit of a difference, and we'll discuss that difference about polarization and whatnot. And this one is considered a little bit cloudy, right? And the reason why is because of the dust and the gases that's actually around it, or what they call an accretion disk. On our black hole. Peace, Gina.
And another reason, excuse me, I'm sorry, what'd you say, Miss Juju?
No, I was shouting out Gina in the chat. I just,
okay.
Because I'm happy they're like our regulars now, and I'm just so excited. And thank you so much. Go ahead, Anthony.
Okay, that the picture is kind of fuzzy because it's like a first generation picture. You know what I'm saying? The technology is getting better, and they have better pictures of the black hole. Now, this itself, you see the hole in the middle, that's not the actual black hole. That's the shadow.
Wait a minute. Can y'all tell me if y'all see that big arrow? Can y'all see my cursor? And I'm pointing at the middle. Give me a 1 in the chat if you see it. But go ahead, Anthony.
But yeah, that's more or less the shadow of the black hole. It casts the shadow. You know what I'm saying?
Wow.
And the disk around it, that would be the accretion disk.
The accretion disk.
You know what I'm saying? Right. And that's, you know, high energy particles, you know, dust. You got stars in there, all kind of stuff in that accretion disk, you know, that's orbiting that black hole. And the closer it gets to that, where it's dark, you know, that's, you get into the event horizon. And that's the area where, you know, there's no return. Once the light hits that event horizon,
It's dandada.
It's gone. You know, you won't be able to see it anymore ever. So that's why you don't see anything in that dark spot in the center, you know, like a donut. And it's brighter, those brighter areas is where, you know, the light is actually closer in the orbit. You know what I'm saying? It's kind of like it's closer to you so you can see it brighter versus, you know, on the other side of it,
right,
where it's kind of dark because it's taking that light longer because it's harder to get away. You know, it's moving so fast. But like I say, once it hits that event horizon, it's over. Now,
so
there are other ways to detect them. You know, they emit light in the X-ray and ultraviolet, but it's, like I say, it's the effects that it has on the other particles, you know, photons, and there's a lot of stuff going on in that accretion disk. It's a lot going on there. So, but those items, you know, are so hot that they're emitting X-rays and ultraviolet rays. So we can't detect those with the eyes, but we can feel them. And if she wake up and decide that she ready to destroy this galaxy, that's what she gonna do it with, them ultraviolet rays.
So I'm gonna give you a few more facts on our Sagittarius A in the middle of our galaxy. So this colossal
I'm sorry,
astronomical
Miss
structure.
Juju.
I'm gonna get in a minute. Let me land this. So the colossal astronomical structure is approximately 4 million solar masses. And if you all remember when we discussed solar masses, that means that it's 4 million times the mass size of our sun. It's also approximately 26,000 light years away from the Earth. And in May 2022, scientists revealed the historic first images of this supermassive black hole, which I just showed you, located here. But the first image of a black hole was actually captured by the Event Horizon Telescope, which is known as the EHT collaboration in 2019. And the image is that of M87 galaxy black hole at the galaxy center. That galaxy is 55 million light years away from Earth, and it is known as a spiral galaxy.
No, that's an elliptical galaxy.
Oh, okay, an elliptical
M87, yeah.
M87.
It's a big round. It's huge, and it's more round than. See, like the Milky Way is a spiral galaxy. You know, we got the arms, kind of like a pizza. But that M87, it's an elliptical galaxy.
Okay, well, the picture you have here is the picture of the black hole in the middle of M87 galaxy for you. And as you can see, it looks slightly different. And from my understanding, those striations in the picture is from the polarization, but I just think they're pretty awesome, right? Everything about this is pretty awesome. I'm going to tell you a little bit about the Event Horizon because I think that is a pretty neat endeavor. The Event Horizon is called a collaboration. The reason why is because it's an international collaboration capturing images of the black hole. The Event Horizon was developed specifically to observe event horizons, okay? Pretty much, but how they did it is with this collaboration of telescopes around the world, basically made a virtual Earth-sized telescope. So this long-standing goal of astrophysics is to observe the immediate environment of a black hole with angular resolution comparable to that of the event horizon, as I've spoken of. The collaboration is the technique of linking radio dishes across the globe to create an Earth-size interferometer.
Interferometer.
Interferometer. Look, I got trapezium down, so y'all got to give me 5 points. But I get interferometer by next week. I promise, because I'll mess it up. But it's a very long baseline interferometer, or it's called the VLBI. At a short wavelength is what the technology is. Did you want to add something to that really quick?
Yeah, they have one located in Livingston, Louisiana, and they call it LIGO, which is the Laser Interferometer Gravitational Wave Observatory.
That's in Louisiana?
Yeah, it's in Livingston, Louisiana.
Okay.
Ain't too far from Angola. Yeah.
But, dang. So
yeah, but what they do with it is, okay, they take one single laser beam and they split it.
Mm-hmm.
And the observatory is shaped like an L, you know what I'm saying?
Mm-hmm.
It's sort of like, like this. And they take that laser beam and they split it down two long, I guess you can call them tubes, but they like maybe about 3 to 4 miles long, each one. Mm-hmm. So they take that single laser and they split it and they bounce it off a mirror, it goes down and comes back. And if there's an interruption in the travel of that laser, mm-hmm. they know they got a gravitational wave. So that's basically how it works.
That's hot.
Yeah, that's dope. And they also been planning on putting one in space, but we'll get into that in a minute. Okay. But yeah, that's dope.
Were you gonna answer the question on the screen, or address, the question on the screen?
Yeah, that so what's being said now, black holes, they actually warp space and time. Mm-hmm. The fabric of space and time. Space and time is said to be woven together and it acts as a fabric. Black holes spin so fast and they're so massive to where they take that space and time and just twist it, to nothing. So it's theorized that time stops in a black hole. That's, but we don't know that for sure. I mean, we don't even know what a black hole is.
Really?
You know what I'm saying?
Sure. Yeah.
We know it's not a hole. We know it's something. And if you listen to that video I was telling you about, that interview, he'll tell you it's real. It's something.
It's definitely real.
Because it casts the shadow, mm-hmm. and they move. We have what they call rogue black holes that's just floating through the Milky Way.
That's
what I'm saying?
That's crazy. Don't come this way.
Yeah, you can't see them, but you can see the effects that they have. You know what I'm mm-hmm. saying? So they are something. It's not an actual hole. So don't let that word black hole make you think it's a hole.
Right.
But it's theorized, like I say, that time actually stops. You know what I'm saying? So, mm-hmm. but how to test that, we don't have the technology yet. But hey, maybe somebody in the chat, maybe one of their grandchildren, or you know what I'm saying,
figure it
be
out.
the one to figure it out. You know what I'm talking about?
Facts. So I talked about this camera called the Event Horizon, right? Which is this joint international collaboration with these telescopes strategically placed. Mm-hmm. But Event Horizon actually part of the black hole phenomenon. And so I'm going to go ahead and get into that a little bit really quick, and then we'll cover it a little bit more later. Not too much, really. I'll just tell you just give you the placement of it. But right now, what is an event horizon? Well, in astrophysics, it's a boundary beyond which events cannot affect an observer. Wolfgang Rendler actually coined this term in 1950s. Black holes are astronomical objects that can also cause gravitational lensing. Remember, we spoke of gravitational lensing, right? When we did the episode discussing, these very distant stars or whatnot. And black holes are one of those masses that are known to do that lensing. Remember when we talked about having the sheet of rubber and putting the different size balls on them, and that curvature, and how that curvature magnifies the light and makes it pretty much available for us to see, and the black hole is one of those astronomical objects that gravitationally lenses other astronomical phenomena or whatnot. So also this lensing can also cause objects to redshift. We also spoke about redshift. I was going to get into a little bit into it, but what we know about redshift is that it basically gives proof that the galaxy is expanding. If you want me to talk more about it later or whenever, ask me, because I definitely, I definitely have it down pat. I figured it out. Okay. How are black holes forged? Did you want to add on something real quick before I get into how black holes are actually forged in nature or in the?
Nah, go ahead, Miss Juju. I'm answering a few questions in the chat. Go ahead, you rock.
Got it. So how black holes are forged? Well, the first way a black hole is forged is by the death of a massive star, making the initial stellar corpses. We talked about kilonovas, right? The death of two neutron stars colliding. And Kent be on it. Dang, Kent, you must have took a class. Right? I ain't mad at that. But this is the initial way that they form. This will happen when the star's birth masses are approximately above 8 to 10 solar masses. Remember I told you about solar masses? And when they run out of fuel or hydrogen, they pretty much explode and die, leaving behind a very dense compact mass, which is a black hole. This is correctly referred to as a stellar mass black hole. The second way a black hole is forged is from the direct collapse of gases, meaning there's no star in sight, but you have these gases, and these gases for some reason just collapse. And the amount of formation bypasses the formation of a star and is believed to have been the dominant way, especially early on in our universe. They're thinking this was the best explanation they have to how we get these black holes, because we'll get into later how them black holes was out there, right? We really have a lot of stars, but we had a lot of black holes. So and we're still figuring this out. A lot of the dates, as you notice, aren't like really old dates, right? They're very recent. So this is some really, what is the age we're in? The golden age of science, and particularly like in astronomy. This is considered like the golden age, because we're really getting to the
You'll hear some scientists refer to us being right, smack dab in the middle of a golden age. At least I think so, because if you just look at how, and I know most people are not into this like this, but astronomy has taken off the last few years, and with astrophotography, oh my goodness. I mean, it used to be only you could do, get this kind of stuff from Hubble. Now everybody or anybody can go by this. This is a Celestron C6. All this my electronic stuff is by ASI or a company called ZWO. My mount is a Skywatcher. So anybody can do this now. A few years ago, we had to wait on Hubble. Well, we don't have to do that now. You know what I'm saying? So when the science becomes available to the layman, and the technology becomes available to the layman, yeah, you're in a golden age. And like you say, Webb is just rewriting a lot of the things that we thought we knew. We got to update it. You know what I'm saying? The information got to be updated. So yeah, we're in the middle of a golden age.
We get into it though, right?
Yeah.
So the second process of black hole formation is interesting because, again, they theorize that this is how black holes, initially started in the early part of the universe. But this process is pretty amazing. Remember, I told you like 100 million black holes in our galaxy alone, right? So the second process, which is just the gas, no star formation, is expected to produce more massive size black holes that range from, listen, y'all, 1,000 solar mass to 100,000 solar masses. That's huge, right? Who discovered black holes? Well, this is where we talk about science takes steps, right? How it, it just doesn't manifest automatically, or, one person has control of it, because it takes so many participants to actually get, the answer close to what we think is the answer, right? But to start, actually in 1784, I believe, the idea that an astronomical body so big that even light couldn't escape was proposed by John Michel in a letter that he wrote back in November of that year of 1784, y'all. Damn, that's pretty dope. He assumed that such a body might have the same density as the sun, thus naming the theoretical celestial body a dark star. So in 1915, though, black holes were predicted as an exact mathematical solution by none other, Albert Einstein, and equations of general relativity. Einstein's equation described the shape of space around matter. The theory of general relativity connects the geometry of shape to the detailed distribution of matter. Now, to add on to that step, you have a few months later, that same year in 1915, you have Carl Schwarzschild, who discovered a black hole solution. He concluded that these regions, known as black holes, were found to extremely distort space and generate a puncture in the fabric of space-time. So those are the major players. And of course, you got some Stephen Hawkins in there that did some things. I think actually before the discovery of the first black hole, which was Sigus X1, and I'll talk about that in a little bit, Stephen Hawkins actually places a bet with another scientist concerning whether it was a black hole or not. And he actually, Hawkins, excuse me, I always say his name wrong. He actually lost that bet. That's just a little bit of, scientific, extra information, so to speak. Also, the term black hole was coined by another American astronomer, John Wheeler, in 1967. And this was right after they discovered the very first black hole ever detected. And that was Sigus X1. And if you give me a moment, y'all know I got Sigus, right? Y'all know I'm finna show y'all. I'm finna show y'all Sigus right quick. Let me get Sigus up for y'all so y'all can see what we working with.
That's one that Dr. Farrar and I talked about,
Nice.
Cygnus X1, which, that was a nice discovery.
Yeah.
And they discovered it using, I think they could detect the high source of energy, but they couldn't see where it was coming from.
Yeah.
You know what I'm saying? So that's a pretty dope story how they discovered it.
It is. It was they said a sound rocket detected a celestial source of X-ray is what it was, and that was in 1964. And so in 1971, astronomers determined that these X-rays were coming from a very bright blue star, and this blue star had to be orbiting something very dark, very massive. And the reason why you were getting these X-rays because it was a result of that very dark, massive object stripping away at the stellar material of this huge, bright blue star. That's how they found this black hole Sigus, which is the first black hole detected. Do black holes die? Well, per se, maybe. And this is one part of my research that Steve Hawkins actually, kind of really gave his input on. So it's theorized that over an extremely long period of time, longer than we probably can ever fathom, that eventually they evaporate, right? And this is the loss of energy and matter. Black holes grow by the accretion of accumulating matter of matter nearby that is pulled into their intense gravity. Stephen Hawking theorized that black holes can also radiate away energy and shrink very slowly. And now we're going to get into some characteristics of black holes, which I thought was interesting. And I hope y'all loving the visuals so far. I wanted to give y'all one or two more. I'm gonna leave Sigus up for a little bit. I'm gonna leave Sigus up, and Sigus is actually a constellation. It's a swan. I believe Sigus is a swan. Is Sigus? I don't consider the swan or the unicorn. It's the swan, y'all.
Yeah, it's the swan, and you can see it pretty good this time of year. If you go outside, look northeast, more north, and you look at maybe about, northwest. I'm sorry, not northeast, northwest, up in the sky. You'll see, 3 stars going across one line. It looked like a swan. Looked like it could be a swan,
That's super pretty. I think that's pretty awesome.
It's, I don't know, to me, it looks like it could be I see it, but you can see that constellation there. Now you can't see Cygnus X1, but you can see the constellation.
The constellation. Okay. So black holes don't emit or reflect light, right? Making them effectively invisible to telescopes. Scientists usually detect black holes, and we spoke about this earlier about they basically study things around them and how they act and how, the gravity of the black hole actually affects those other surrounding objects. Black holes can be surrounded by an accretion disk. And this again is that ring of stellar gas and dust. The disk can emit light across many wavelengths, including X-rays. So I'm repeating and saying this to reiterate some of the ways that these invisible astronomical objects can be detected, right? The intense gravity of supermassive black holes can affect the orbit of stars and cause them to move around. And of course, this is the very thing and that Anthony discussing how we figured out about Sagittarius A in the middle of our Milky Way. And mind you, that also with that discovery, that gained a Nobel Prize in 2020 concerning, Sagittarius A and that whole study. Phenomenal.
Andrea Gies, y'all need to check her out.
We definitely got to check her out. I got to add her in. And that's another thing I'm going to throw in really quick. Also in the descriptions, I do hashtags, so you can go on there, and even especially the ones that they always put at the top. Usually they'll put Neil deGrasse Tyson and Armin Ra, and those people that are kind of known on YouTube or whatnot. But one that's pretty two that I think pretty awesome and is Mogiga Cooper and Jedidah Isler. Jedidah, actually, unless that D silent. Okay.
Yeah, it's silent.
Okay.
Trust me, it's silent.
Isler, right?
Hey, but you know something, Miss Juju? I did the last Black History show that we had. That she was the one that I did it. I did a presentation on her.
Well, you need to get that video.
Y'all need to go. Yeah, they need to go into the archives.
Man, you should give me that video and I'm going to drop in the description. But push their hashtags, especially Mogiga Cooper. Both of the names I just mentioned, as beautiful and as different as they are Black women, African-American astrophysicists, okay? And one of the links that I did do for the link share is actually featuring Mogiga Cooper. Okay, so please go check them out. And if you do go and you can leave a comment, tell them PseudoKillas sent you, okay? So we can get them over here and talk to them and whatnot and let them know we watching. We see you, sister. You feel me? Because that's for real. We got to support each other in what we're doing. And I think that's super, super amazing. When they're very massive celestial objects, accelerate through space, they create ripples in the fabric of space-time called gravitational waves. Also, by observing the effects of these ripples or waves on detectors, scientists can detect possible presence of a black hole. And of course, like we spoke earlier, gravitational lensing can be used to detect isolated black holes, which is pretty amazing. And one of the ways that they do detect these invisible objects. What do black holes look like? Well, they can look like a couple of different things, but we're going to give you this right here so you can follow on going through what they actually look like for you. This is a breakdown of a black hole. So basically, you have 3 layers, right? Hopefully you can follow, and I'm going to start on the outside. You have the outside is this cloud of dust and gas, the accretion disk. And as you are going towards the first inner layer, so you have the first outer layer, then you have the second inner layer, or the event horizon, and that's going to be somewhat of the barrier between the actual singularity, you have the event horizon, you have the singularity, and that singularity is in the actual very middle. So again, once you cross that event horizon, there's no turning back. The event, once an object crosses the event horizon, it can't leave, right? Because gravity is constant across the event horizon. And the third layer, or the region that we call like the black hole, the main part of it, is where the object's mass lies, is the singularity, the single point in space-time where the mass of the black hole is concentrated. So
we have to, before you go on, Ms. Juju, we have to be clear that that's theoretical. You know what I'm saying?
Right.
Because
you'll
get somebody say, well, ain't no singularities. No, that's theoretical. I mean, we don't know.
Right, because we go.
Period. Point blank.
I already been sent a paper talking about singularity don't exist and da 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 da.
Yeah. So we know that you can't find a singularity nowhere else in space. No, right. I mean in nature, nowhere. Already. So we understand that. That's theoretical. It's theoretical because everything that we know that has mass has a center. Right. Just like the Earth. The Earth's center of mass is the core. You know what I'm saying? So that's but the gravitational effects are so strong to where, we have to, I guess you say, consider that. And the mathematics says that it's there, but we just don't know. We don't know. Yeah. So this is a nice picture of, just if you want to reiterate or teach, this is out of Wiki. But of course, I put the all of our sources that are used for this presentation in the description box. Okay. But that's pretty much, your theoretical picture of a black hole. Now we're going to it is nice, right? We're going to get into you see those where it says the relativistic jets? Yes. This right here, this long thing coming out the middle of it. Now that's not actually coming from the black hole itself. It's coming from the accretion disk? Yes, through all that accretion, in everything moving through the accretion disk causes a lot of friction. There's a lot of friction going on in there, plus a lot of what they call them, magnetic fields. Yes, and they're all getting twisted and turned, and and this is another thing that lets us know this is not a hole, because that jet comes out the poles, the north and the south pole of the black hole itself. So it's not an actual hole. A hole doesn't have 2 poles. Right. You know what I'm saying? It's something round. Whatever it is round because it has 2 poles. It has a north pole and a south pole, And those relativistic jets let us know that. You know what I'm saying? And that's what we would call a quasar. When
Yeah.
a quasar with jets. Now, if you don't have those jets, but you have that accretion disk is glowing, that's a quasar. But the most powerful quasars are the ones that have those jets coming out, because it's something going on with that black hole when you see them jets.
Yeah. That's how they always show the quasars too. They show them as really bright, and they show them as like these, you know, kind of pointers or whatnot. You know, that's how I've seen it in my research, and those are always like quasars. So I was like, okay, interesting.
Yeah. Now that's some power right there. And if your girl Sagittarius A star decides she ready to is she ready to knock all the bitumen out of our ass?
Yeah.
That's how she gonna do it.
Not knock the bitumen out there, motherfucker.
Hey,
the bitumen out there, man.
And that's some physics that the Egyptians ain't know about. I promise you that.
Talk to them.
Hey, I can promise you they ain't know about that. You know what I'm saying?
Oh my God, that's too funny.
You see these cartoons being put up with what his name, Geb, holding up whatever.
Nut.
When I saw that, I say, damn, they think the earth flat. You know what I'm saying? But somebody say that was physics. No, that's not physics, y'all. This is real physics right here.
This is real.
You know what I'm saying?
Talk to them.
And being able to actually get a picture of the shadow and the event horizon, to actually be able to get a close-up picture of it using technology with a telescope the size of the damn earth.
Right.
You know what I'm saying? Linking these, that's some technology. That's something that we can do and use in the real world. You know what I'm saying? And become and not just the quote unquote initiated. I'm not initiated in nothing. You know what I'm saying?
To know no secrets, Anthony.
Ain't no secrets.
Ain't no secrets. Right.
None whatsoever. So, hey, this the real shit right here. Pardon my French, y'all, but you know, I get excited when I get to talking about this stuff. I'm sorry.
Look, we already apologized for the Sharon. You know what I'm saying? They ain't gonna kill them. They're not gonna be traumatized forever, but we try not to. We do try to keep it, you know. It's PG-13 though, so you know, just to let y'all know. So I think shit is a PG-13 word. But moving on. So we got several types of black holes, which, okay, now this is the part that really surprised me, Anthony. I wasn't surprised by anything else because, you know, we really don't know, right? But this, I was like, well, dang. So, you know, I got like a Honda black hole. Then, you know, I got like the Maybach or that Chevy Impala version of the black hole. And, you know, then or no, should I do like a semi truck version of black hole? And then I got like a pickup truck version, and then I got like a sedan version. That's how I do it, right? So stellar black holes, I already told you all about how what stellar black holes are in the beginning, because those are like the initial way they're forged. You know, you got a star, it dies, it leaves a black hole, pretty much. But these are also considered like some of the smaller black holes. And then you have the black holes that dominate across the universe, and these are supermassive black holes like Sagittarius A that we just told you about, okay? And these can be millions or even billions of solar masses in size. And I already taught y'all about solar masses, but if you need to know, a solar mass is the size of our sun. So take the size of our sun and multiply it by a million or a billion. There you go. I'll let you do the math because that's not my strong point, but I think y'all get the picture.
Hey, they get the picture.
I think
you take 4 million of our suns, what we see today, to make or to come up with the mass of the Sagittarius A star. So when she says 4 million solar masses,
it's 4 million.
Everything is measured off of what we know. Remember, I told y'all that on the last show.
Right.
What we know and understand, that's what we measure by.
That's the template.
A solar mass is the mass of our sun. So if something is 4 million solar masses, you have to multiply 4 million by the mass of our sun. And I know that exact number. I'm sorry, but
That's all good.
quick Google search.
And when you leave the sources in the descriptions, they can go there too. And I left y'all some bomb good sources. This show for real, I was like, oh, I'm giving up, yo. It's them gifts before Christmas, right? But so it's theorized that supermassive black holes are probably at the center of every galaxy. And I'm going to say probably and theorize and approximately because that's where science works. And again, when we're talking about black holes and black hole science, so to speak, that's still working in progress. And we only can go by the information that we know at hand. And that's what we know. We're not going to make it up, okay? And we're definitely not going to lie about it. We don't have no need to do that. These dominate as the type of black hole located in the universe. Unsure of how they are forged. So the thing with supermassive black holes, they know how you get stellar ones, but they're not sure how supermassive black holes are forged. They say that they can be a product of 100 or even thousands of smaller black holes that merge into one, or just a large gas cloud. Because remember I told you before, the other way besides stellar is just a gas cloud without the star, or whatnot.
That's called direct collapse.
A direct collapse. Thank you.
Yeah.
So they're just saying, well, maybe there's this huge, large gas cloud and, it collapses and voila, you got this huge, large, supermassive black hole. Also, it could be where a large cluster, a large stellar cluster, because we have star clusters. So it could be that the star cluster, did a little thing and they all exploded, or they was born around the same time, they exploded around the same time, or it was a chain reaction and that happened. Or this is the one I really like, similar to black holes, or that it was actually a cluster of dark matter. So this was interesting to me, dark matter, and this is where I'm leaning on, like, yeah, that definitely could be it, because dark matter and black holes are very similar, Anthony, right?
Yeah.
And I'm gonna read a little bit, and then I'm gonna let you get in it, Anthony, because we actually almost to the end. But we did good though. So similar to black holes, dark matter is a substance or celestial phenomenon that can be observed only through its gravitational effects on other objects. Sound familiar, y'all? Scientists don't know what dark matter is or what it's composed of, due to the fact that it doesn't emit light and cannot be directly observed. So yeah, I mean, that makes all the sense to me. They kind of correlate. Did you want to go in a little bit on that before I continue?
Yeah, it's actually the dark matter is way more important than the black hole, because believe it or not, it's the dark matter which keeps the galaxies together, not the black hole. You know what I'm saying? Now you have a lot of things orbiting the black hole or whatever, and the galaxies have a spin to them for the most part, but things at the outer edge of stars at the outer edge of most galaxies is moving at the same speed as the stars in the inner part of the galaxy.
Fact.
And you're like, hold up, wait a minute, that ain't right. That shouldn't be happening. So there has to be something else acting on these galaxies to keep everything in line, because the galaxies should be flying apart.
Yeah,
that was one of the
some kind of galactical fabric, keeping them. Yeah.
So that's what one of the first thoughts of what brought up the thoughts of dark matter. And then, like you said, it doesn't interact with light, but it can affect light.
Right.
You know what I'm saying? It affects, because
just like the gravitational waves of the black hole, though, it doesn't emit anything, but it definitely affects it, right?
And see, photons are actually massless particles. They don't have any mass. You know what I'm saying? So the black holes and the dark matter, we can see how they bend light. You know what I'm saying? They make light go on a different path. So wait a minute, but you just said particles are massless. You know, photons are massless. So how is that happening? Well, they have to be bending the fabric that the light or whatever it is that the light is traveling through or on has to be distorted some type of way. And what is distorting that? We don't know. So we call it dark matter. We call it a black hole. You know what I'm saying? Because we don't know. We don't have that level of understanding yet. And that's a dope quasar you got up there right there. That's dope.
Oh, you like that?
With them jets on there.
Yeah, that was the artist rendition, actually.
And another way we know that they are real is because black holes actually do merge. And thanks to gravitational waves, we know that. So, yeah, this stuff is real. It is real.
Yeah, what I'm showing now is actually what I was going to get into later. This is actually a artist rendition of a binary black hole. I erased it, but I was trying to get to this really pretty photo that they have. I so messed up. I'll get back to it in a minute, though. Even though it was thought that there were only two sizes of black holes, small or large, like I said, we have a middle-sized one, y'all. So they only thought there was stellar mass and solar and super massive black holes. Stellar mass black holes and supermassive black holes is what we thought we had. But we also have what we call IMBHSs. And these are intermediate black holes, basically. So they're right in the middle. In 2014, what appeared to be an IMBH was discovered in the arm of a spiral galaxy. And in 2021, an ancient GRB, and because I'm not going to say it, I want somebody in the chat to guess what the GRB is, because we done talked about this, was used to detect, as we spoke about in the Killanova show, these intermediate black holes. 2018 research suggests that these type of black holes may exist in very small, or what we call dwarf galaxies, right? And the final type of black hole, by far the most interesting, is what you see on the picture, ladies and gentlemen, is a binary black hole. In 2015, using the laser
interferometer. Yeah.
I got trapezium, so I'm good. Interferometer. The Laser Interferometer Gravitational Wave Observatory, or LIGO, right?
Yeah.
Yeah. That's the one in Louisiana he was telling you all about. This detected gravitational waves from merging stellar black holes. Also with the technology, scientists have confirmed stellar mass black holes. Sorry if I'm saying stellar. I'm ADD like a mofo. Stellar mass black holes with a solar mass of 20 times the mass of our sun. Objects that scientists didn't even know exist. So this technology of LIGO and the other technology of the Event Horizon is giving us insight also in the direction of a black hole spin. This is interesting, right? So now they can figure out that black holes can either spin together or they can spin like opposite of each other, right? And I'm gonna tell you how this happened real quick, and pretty much I'll show y'all some more pictures, and you can go eat some cake now. But so there are a few theories on how these very unique astronomical bodies form, right? The first theory is that two stars, and I'm talking about the binary black hole system, if we can call it that. Of course we can call it that. Which is
mind-boggling.
It's mind-boggling, isn't it? I was like, whoa, I did not see that coming. You got two black holes? I don't want to see two black holes. One black hole, okay, but two, I'm scared. I'm finna go out. Shoot, they ain't nowhere to go, y'all. They ain't nothing.
Where you going? Where you going?
But listen, that's what humble you. That'll humble you real quick. Y'all better look. It's like telling all the children on the planet, y'all better behave. Look, Palestine and Israel, if y'all don't get y'all mess together from Mama Black Hole and Daddy Black Hole, come home. Look, we're in trouble for real, right? I figure that's how we're humble. But so the theories on it is that the first theory is that two stars born together died explosively approximately around the same time. And that's one way you can get the black hole. And because of that formation of them being, born around the same time or at the same time, then dying, then we know that the companion star went into the same direction as the other star. So the black holes will go into the direction as whatever star was formed, pretty much. That's the information that they know now. Now, the other way that they're theorizing is that the black holes in a stellar cluster sunk together to the center and paired up. But because they weren't necessarily like binded together in a sense, like they wouldn't necessarily have the same rotation. So this is where you get two binary black holes, and now they're rotating opposite of each other. So yeah, but thanks to LIGO, that space technology, and that's why I kept saying not just the James Webb Space Telescope, but LIGO and the Event Horizon. I mean, we have all these tools and equipment to give us these phenomenal answers to our questions, and also, giving us more questions to answer. And you got people out here talking about, oh, it ain't real, it's a hologram, the earth flat, just crazy nonsense. Like, how can you come up with some stuff like that knowing what we know? You know what I'm saying? Just by the five, this is our fifth show, our fifth installment. By the 5 shows that we've done, if y'all were on the edge to thinking one way that, dang well ain't right, and this thing help you get back together, like back to your critical and logical thinking sensibilities, to see that can't possibly be. I don't know what to tell you, but I tried. I will tell you that I sure did. I tried to help. I did try to help. And with that, ladies and gentlemen, that concludes my presentation for the evening. And I hope you enjoyed the pictures. I thoroughly did. Yeah, I might got 1 or 2 more to share while you want to give your final critiques on some things, Anthony, because I really want to find this one more. I'm going to find it, y'all. Don't go nowhere. Go ahead, Anthony.
Oh, no, you've been rocking, Miss Juju, doing great. And I'm loving the interaction in the chat,
Interaction in the chat is fire tonight.
Yeah. But like I put in the chat, I don't know if everybody saw it, but when you think about space and time, you can't have one without the other. You know what I'm saying? If Miss Juju get up and walk into the other room, it's going to take her time to cover that distance. You know what I'm saying? So she's created space and time in between herself and her computer. And it's going to take her time to get back. Now, the rate changes because, things move at different speeds. But fact of the matter is there's space and time in between her and that in her computer. You know what I'm saying? So that's basically why they say space and time are woven together like a fabric. And we get the fabric part due to what we just talked about, very massive objects. They distort that fabric, but photons, like we say, are massless, so they follow that distortion that's created by the dark matter, by the galaxy clusters, and, by the black holes. You know what I'm saying? So that's basically, like this picture right here. This is the Earth. It's a small, compared to a black hole, that's a little small dimple. But you see that graph, those lines, that's space and time. You know what I'm saying? And that's what the gravitational the mass is affecting. That's kind of, that's a very good visual. Now, if you look at, you bring a photon through that, the photon is going to follow that distortion, you know what I'm saying, that the Earth is making. And our sun, it does the same thing, which, you know, was proven back in 1919. You know, we talked about that last week. So yeah, that's a pretty good visual, right? Well, all of them been good though, Ms. Juju. I see you've been on it.
Yeah, I be on it. This one was pretty awesome too. This is they actually named this the Schwarzschild black hole with the galaxy passing behind it. You know, remember he was the guy that came up with, what is it, the solution to Einstein's equation?
Yeah, he found one solution which led to a black hole. Yeah.
But I actually found it. These are just some explanations of lots of the stuff we just spoke on, but in a more diagram or scientific manner. But you know, if you want to revisit these, I drop the link for you in the description box. So be happy to go back and visit. Polarization, the strides. And this is the M87 black hole in the M87 galaxy. And I'm sorry, so I'll show you the difference. This is the Sagittarius A in the middle of our Milky Way. And this is the M87 black hole in the M87 galaxy.
Now, so this is also better, you know, the first picture of M87 kind of looked like
the Sagittarius A.
This, the one you're showing now, M87, that's a better, you know, they, like we said earlier, they advanced the technology and they're getting better at it. And those things spin. I forgot to talk about.
They do spin.
They spin crazy
really fast.
Yep. And they are dragging space and time with it. You know what I'm saying? So that's why, you know, I was saying, to answer the other question, that time will stop.
Another thing that I was reading is, like, you know, so sometimes objects that come near the event horizon or whatnot, and before they make it past the threshold, they would get bounced off, and something like the velocity becomes that of the speed of light or something like that. Am I getting that right?
Say that again, Ms. Juju.
They will bounce off, and so they can project objects, and they can project objects so fast and with force that they can move almost the speed of light.
Yeah. If there are things that get ejected out of that event horizon, like I say, you can have whole stars in there. You can have binary stars in there. And there's also an article out there. It came out back in maybe 2017. I'll see if I can dig it up. But they're thinking this was caused by 3 black holes orbiting each other, and one of them was ejected. And so you got a black hole streaming across the galaxy. You know what I'm saying? And it's a supermassive one too. It's big.
Right.
But it's so far away from the center, and it's moving so fast away. And when they do the math and run its trajectory going backwards, they see that it was ejected by 2 other supermassive black holes. And that normally happens during galaxy mergers. That's how you get, because you only find 1 supermassive black hole per galaxy pretty much. You know what I'm saying? Now, during the galaxy mergers, when that happens, then you can get that kind of interaction with those 2 supermassive black holes merging, and the gravitational waves that are created in that throws one of them, kicks one of them out. You know what I'm saying? So it's dope. You know what I'm saying? It's something to really think about. And then, like we were saying earlier, you got over 100 million stellar mass black holes roaming through the Milky Way, just out there doing their thing. You know what I'm saying?
Right. Well, when we get to the rogue ones, that's hot. But this picture is what I was looking for real quick. And this will be my final one, and we'll wrap it up. But this is a swirling vortex of hot gas, glows in this multi-wavelength composite, marking the approximate location of the supermassive black hole Sagittarius A. And then the middle is the gas flow. I thought this was beautiful because, y'all know how I love pictures. And doing the research, I was like, oh man, this is right up my alley. pretty much a picture book of the galaxy. I love it. A picture book of black holes. So if no further question, or if nobody wants to hit the panel, I thought I dropped the link in the chat.
Yeah, I think you did.
Me and Anthony is just gonna wrap it up. We don't want to make it too long. Again, we just want to give y'all bite-sized information, enough for you to digest easily, but also enough to make you want to come back for more. So, if there's any questions in the chat, I'll give you maybe a minute and 30 seconds or so. And, you can put them in the chat, or you can hit the link real quick. If not, we're going to get ready for another Pseudo-Killer Community of Skeptics production later on this evening. But again, we just want to thank everyone who's been coming and supporting us weekly for this endeavor, learning some science with me and Anthony. It's pretty awesome. I absolutely love it. It's fun, and y'all make it fun. Y'all make us, want to do this continuously, and we just appreciate it. I can't express enough how much we appreciate the support. Absolutely amazing. Anthony,
time.
anything else you want to say before I go ahead and play that cut?
No, I just want to thank everybody for showing for supporting us and engaging.
Yeah.
You know what I'm saying? That's what, warms my heart.
Definitely.
You showing up.
Yeah, it's popping tonight.
Really showing up, yeah. And with some great legitimate questions.
Exactly.
Not no foolishness. You know what I'm saying? Some good questions. And I just put up the evolutionist. Man, you've been on it, dude.
Yeah, the evolutionist is sharp. I just want to let you know. The evolutionist is sharp, and I wish he'd come by more often. I just wish you, join and commune with us. And thank you for supporting us. Thank you for supporting. I know the evolutionist. I'm very familiar with him. So I just want to say thank you. Thank you to Mantu 2.0. And there's certain people I'm picking out because I think we can get caught up in some of the hoopla and some of these conversations in the quote unquote community. And listen, I'm about solidarity, and that don't stop me from doing what I do, or communing with a certain person. You know what I'm saying? I don't really like to get not rah-rah, but if I got to, I'll turn up. But that ain't what it is about. So it's nice to see faces that I know from opposing platforms still coming and supporting what they know is some correct, rightful, downright rah-rah free information. So I appreciate that. I really do. And you, like I said, this ain't about cliques and gangs and, this and that. This is for the babies. Like, you gotta, like I said, when them binary black holes, Sagittarius A, mama black hole, and, and the papa black hole come and they see like Earth is, doing the rock, and they decide it want to be over. It's over. None of that is going to matter. Not none. And like Kent say, that cosmic perspective, we really need to get on it, right?
Yeah, we do. We do.
So maybe we'll talk about that more in the next show. But until then, ladies and gentlemen, thank you very much. And you know how we like to do it. We got to do it with a, as DQ Hampton say, he is our resident DJ, songwriter. Like, he and my Dirty South Mount Rushmore top 5 for real. But we're going to do something for the ladies tonight. You already know how it go. Lady Killers. Good night, y'all. Peace. And thank you.
Peace.
Yeah, it's DQ, baby. PseudoKillas, what up? Check. Tapping in, what's the subject? Evolution or revolution, we ain't done yet. Laying flat like Sanchez, this a bomb threat. I know my flow like Angozi. Source up and show me, homie. You shut up and mute up a moment. The mad scientist, I'm knowing all the components. We own it, and we gon' off it if it's pseudo. You do know we don't entertain that keyboard judo. That big body banger out of Baltimore. Done it all, shop before. Sold a little something, but I taught you more than your average garbage teacher. I had to reach it at your level to bring you up. No devil can never beat you. With precision of a magi, the information supplied by some guys get debunked online. CK and JuJu, I chill in the cut. But if you boys wanna fade, then I'm chefing you up. I organized lie, defeats a disorganized truth every time. Kudos, who those niggas? Decorated pseudo killers, SpaceAgeAfricans, back again. An organized lie, defeats a disorganized truth every time. Kudos, who those niggas? Decorated pseudo killers, SpaceAgeAfricans, tapping in. I always been fly, that's an actual omen. You can catch me in the sky, ask Anthony Bowman. See me with his telescope, I was actually floating off some good kush. The Sadio is actually grown. See, Gullah and Kent is where the money gets spent. Them boys got some books that cost as much as your rent. The second verse should be smash Rockwell, but I rock well. Underground like Sumerian Rockwells. In the ring like I'm the rock whale. Hell, create a different wave that can rock whales. Hell, shit swell like lunar tides. My entendres off Gandra to who describe. Euthanize foolish guys. Scholastically, haphazardly. Turn your camera on and look me in my eyes. And please do subscribe. 8 to 80, blind, cripple, or crazy. You in for a new surprise. It's DQ, a organized lie. Defeats a disorganized truth every time. Kudos, who those niggas? Decorated pseudo killers, SpaceAgeAfricans, back again. An organized lie, defeats a disorganized truth every time. Kudos, who those niggas? Decorated pseudo killers, SpaceAgeAfricans, tapping in.